Good afternoon, dear colleagues. Another one paper I would like to present today is the detection of the initial region of the current transformer core saturation. One of the most common problems of any current transformer installed in the world is a core saturation that leads to the distortion of current signal at the secondary circuit. It's possible to fix it using the possibilities provided by digital substation based on the computational method of magnetic flux density estimation. The purpose of this very research is to provide a method that can detect the saturation of the current transformer core with a high reliability. First of all, it's necessary to calculate the flux density value using the following expression presented at the bottom part of the slide. To implement this calculation and magnetic flux density method considered in the paper, it's necessary to know the following parameters of current transformer. Generally, there are some parameters presented on the slide, and among them the most important are magnetizing curve, secondary circuit resistance, secondary circuit inductance, the path length of magnetic flux, the cross-section of the core of current transformer, and finally the turning number of the secondary winding. The detection of the saturation is based on the fact that when current transformer core enters the saturation region, its flux density changes quickly, and instead of a sine shape, so that is typical for unsaturated mode, it has stationary areas that resemble a trapezoid. In this area, the value of the derivative and sigma, that is the variance of the flux density, sharply decreases. For the presentation purposes here, the upper plot of the figure shows the reference value and measured values against it of the current transformer, and the lower figure shows the change in this reference flux density during current transformer saturation. This means that the measure of the flux density variance in relation to its mean value in saturated areas is greatly reduced. The mathematical content of the algorithm and the method proposed is presented on the slide. So generally, the occurrence of the saturation is determined in accordance with the trigger value. This trigger compares the variance of the flux density with the threshold, and the threshold is calculated according to the least square method of the flux density and some other parameters represented by the formulas. All the calculations are based on the possibilities provided by digital substation standards, and in particular the 80 measurement points at the period of the sine or saturated current wave. To provide the proper operation of the method and the algorithm, it was necessary to handle the noise that is typically provided by the initial phase of the short circuit current and corresponding saturation of the current transformer core. So the initial phase angle was varied from 0 to 90 degrees. The results of the experiment are provided on the slide. As it can be seen from the slide, it's possible to obtain a stable D value that is represented by blue trigger lines, and these values correspond to the areas of the saturation determined by the algorithm and the method, so it's possible to detect saturation and restore the signal. Also, the magnetic flux density sensitivity was checked for the initial flux density. So it was varied in the range of from minus 0.5 Tesla to 1.8 Tesla of the initial magnetic flux density in the current transformer core. And for this experiment, an initial phase was a constant and it was specified as 0. As it can be seen from the slide, there is a stable detection of the current transformer core saturation, so it's possible to detect the region of the saturation. So the conclusion is that a new current transformer saturation detection method has been proposed. For correct operation of the method, a threshold calculation and the method settings are given. This method was checked with respect to noise and the level of the initial flux density. And different function-based methods were analyzed, and the advantages or disadvantages of the method are presented in the paper. Then, experiment results of the paper show that proposed saturation detection is stable and highly reliable. It's clearly seen from the experiment that it's possible to detect the areas using just 4 samples of the measured current. I would like to note that digital substation possibilities provide more than 80 samples per cycle, so there's a great potential to increase the reliability of the method and to detect some other areas of saturation and malfunction of current transformer. The further investigations will include the method of restoring the signal to the initial value. Thank you for attention. I would like to answer your questions.